Okay, we are at part 5 of this video, and we have seen that we've done a complete solution for a specific amount of load on this 3 bucket system. And let's look at some results now, which we can pick bodies with the body filter on here, and let's insert maybe some directional deformation and pick these 3 bodies on the top, or the 4 bodies on the top, and request an evaluation. So we see that there's a nominal set of values there. We can turn on min and max to see where those are showing up. We could even do some slicing to see how that's coming about, and here's the section tool. We can draw a section through those 2 areas, and this is the where we can edit the section plane. So maybe want to see the other side of that. We would click edit. We can switch to the other side. We can rotate the view a little, zoom in a bit, and move the section plane around. May help. Let's duplicate that, but do all bodies. So I'll select all. I'll show all bodies, and let's F7 to fit the view. Control A to select all bodies and apply. So there's another deformation, but with more bodies available. So with this section view, we can click the edit button and show whole elements or not, and we can also move the slice around, and we're looking both at sheet bodies as well as solid elements. And it's a very coarse mesh, but this is just to get a sense for how to use the tool. And so let me bring this back, this section, click on the section, click on edit, bring it back to where the min and max values are, around here, looks like. So turn off the editing to make rotation of this, and potentially turn off some buckets just to look at the soil. So F9 to hide, and back into the deformations. Now the deformations are small numbers of millimeters. I mean, the wall thickness is 25 millimeters. These are 6 meter diameter holes. So if we wanted to take the solution to another point, that's why we used the restart, and the restart of manual can be set to begin at the end of the last load step, and instead of 1 step we can go to 2 steps, and the remote force now in step 2 can go to a larger value. So maybe it can go 10 times further, so just throw an extra 0 in there, and we can start solving, and we're solving from the end point of that last point. And that was one of the useful things to learn in this video, is how to restart, given the setup we did in an earlier video to allow us to do that. And we'll see hopefully the solver output show us that it's beginning the solution. Oh, the update interval is 222. Here we go. So it's a restart. It should tell us that somewhere here. Yep, restart from previous. And let's have a quick look at the force convergence. So there's the completion of step 1, and step 2 was with a lot more force. We expect to see higher levels. So at time 2 hasn't really changed a lot. Let's put another step on there. Step 3, and maybe add a couple of zeros this time. So we want the force in step 3 to be 100 times more than step 2, and it's going to restart. Let's click on analysis settings. It's going to restart at the end of step 2, so we hit solve and see what we get. At some point, if you put a big enough number on it, it'll struggle to solve, and we might see that in the force convergence plot. But this is just playing around. We should spend a bit of time in a video to do a more refined mesh. So here is step 1 completed, step 2 completed, step 3 is attempting to get a solution all in one go, and with just a few iterations it's going to get there, and that's done now. So we're starting to see slightly larger deformations, 55 millimeters, and so it looks like we're on the right track. Potentially the next video will look at how to get a finer mesh to get a little more resolution there. I will show that there's a way to exaggerate the deformations. Maybe 35 is a bit too much of exaggeration, but 10 for example. So an exaggeration factor of 10. I should be able to just type 10, yes, and that is a factor of 10 exaggeration on the deformations. Okay, thanks for watching.